Hi guys, so this is a new video on differentiation under Math SL. We are continuing with the series on tangents and normals, and in this video we shall continue with problems that require us to find the equations of tangents and normals. I shall be tackling the three questions that are on the screen in front of you, and I shall begin question 1 shortly. So question 1 came in paper 2, November 2012, question number 3. Kindly take a minute, pause the video, attempt to solve, and the answer shall follow through shortly. So in question A, you are required to write down the x-coordinate of P, where P is the point at which the curve crosses the x-axis. So there is P, and we are told that this is the point at which the curve crosses the x-axis, and we are given the equation of the function f of x. So in order to find the x-coordinate of P, I simply need to find the zero of this function. And by zero, I mean the point at which the value of the function is 0, or the value of y is 0. So there is a calculator function to do that, and since we are in paper 2, we can just use that. So I've accessed the y equals button, and I've written down the equation of the function as it is provided in the question. I shall then click on trace in order to sketch the graph, and we can see that it looks similar to the one provided in the question. Now, in order to find the x-coordinate of point P, which is roughly 2, we expect it to be 2, but there is a calculator function to determine exactly whether this is the case or not. By the way, we expect it to be 2 because the scale tells us so. So there is x equals 1, and on the second dash or bar or whatever, there is the point that we want. So this is at x equals 2. Anyway, so let's use the appropriate calculator function to do that. So I shall press on second, trace, find the zero of the function. I shall choose a left bound, so the cursor is at a perfect position for that. Next, I shall choose a right bound, so I shall drag the cursor to the right of my point. Then I shall guess where the point is, and I shall drag the cursor roughly to where the point should be. The calculator confirms that the zero lies at x equals 2. So question B requires me to write down the gradient of the curve at P. If this were a paper 1 question, I would have had to differentiate and then plug the x value into the function, so plug 2 instead of x in f dash of x. However, since this is a paper 2 question, there is a fast way to do this using the calculator. So again, second, trace, find dy by dx, knowing that dy by dx is another term for f dash of x. And I shall plug 2 because I want the gradient when x equals 2, which is the value of x at point P. So I pressed on 2, I clicked on 2, hence the calculator shows me that it shall calculate the gradient at x equals 2. I shall click on enter, and the calculator tells me that the gradient is 10.00001. This is just a machine error. It just means that the gradient is 10. Hence, the answer to B is 10. So just to confirm, the answer to question A, which required the x value of point P, is x equals 2. And the answer to question B, which required the slope at P, is 10. Now moving on to question C. I am required to find the equation of the normal to the curve at P, giving the equation in the form y equals ax plus b. So let's take a look at how to do that. So since we need an equation of a line, we need a point on this line and the slope. Now, the slope of the normal line is the inverse of the slope of the tangent line. And we know from question B that the slope of the tangent line is 10. Hence, the slope of the normal line shall be the additive inverse, meaning that I should switch the sign. It shall be negative instead of positive. And it shall be the multiplicative inverse as well. So instead of 10, I shall write 1 over 10. So in simpler terms, you shall simply switch the sign and flip. So 10 becomes 1 over 10 and it becomes negative. This is the slope of the normal line at x equals 2. So what is the y value when x equals 2? This was obvious from the graph. Since this is the x-intercept, the y value shall be 0. Let's take a look. Obviously, at point P, x equals 2, and obviously y equals 0 because it lies on the x-axis. So now that I have the slope and a point, I can just use the point-slope formula. Y minus the y value, which is 0, equals negative 1 over 10, which is my slope, times x minus the x value, which is 2. But I need to write it in the form y equals mx plus b because the question specifically required me to do so. So I will just expand the right hand side of the equation, and of course this 0 vanishes from my equation. So I get y equals negative 1 over 10x plus 2 over 10. So take a minute to copy this down if you will. I shall begin question 2 shortly. So question 2 came in paper 2, May 2009, time zone 2, question 6. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So question A requires us to write down the gradient of the curve at P, and we are given the equation of the curve and the value of x at point P. So we shall use the GDC like in the previous problem. So I've written down my equation on the GDC, and I shall click on trace. There is my graph. I shall click on second, trace, calculate the slope, and then I shall click on 2 because I am told that the x value of P is 2, and I shall click on enter, and the calculator tells me that the slope is 0.6. And like we said before, if we have a lot of zeros and a number at the end, we just ignore this. This is a machine error. Hence, my slope at x equals 2 is 0.6. Now, in question B, we are told to find the coordinates of R, where R is the point at which the normal to the curve cuts the x-axis. This is a bit ambiguous because it's not something you frequently see. However, what you can do is you can just attempt to do the usual things that you do in a differentiation question when they mention the normal line. We are going to get the slope of the normal and the equation of the normal, and then attempt to find out what the question requires. So we are told that we need to find the equation of a normal. Hence, we need a point and a slope. So the normal cuts the curve at P, and we know that at P, x equals 2. So we can get the y value at point P by substituting 2 into this equation. So len 6 minus 1 equals len 5. Hence point P has a y value of len 5 and an x value of 2. Next, we want to get the slope of the normal line, and we know that the slope of the tangent line is 0.6. Of course, 0.6 can be written in fraction form as 6/10, or actually 3/5 as well. So if we want to get the inverse slope of that, we shall switch and flip. So -1 over the slope of the tangent. Since the slope of the tangent was positive, my slope of normal shall be negative, and I flip the numerator and the denominator. Now that I have the slope, which is -5/3, I need to substitute the values into the point slope formula. So y minus len 5 equals -5/3, which is the normal slope, times x minus 2. Hence, this is the equation of the normal. Now, I don't need to find the equation only, I need to find where the normal cuts the x-axis. So, if a line is going to cut the x-axis, then at the point of intersection, the y value has to be 0, because any point on the x-axis has a y value of 0, and you should know that. So, since the y coordinate is 0, I shall simply substitute y here with 0 and attempt to find x. So 0 minus len 5 is just negative len 5, and I shall expand this bracket, so -5/3x plus 10/3, and 10/3 is the product of -5/3 and -2. If I multiply those together, I get positive 10/3. Next, I shall attempt to isolate the x value, and there is some algebra right there. So -5/3x is isolated, and I take the 10/3 to the other side. Of course, it was positive, hence now it's negative because it was transferred to the other side of the equation. Next, I multiply both sides by -3/5 so that the x value is isolated completely. Of course, you can evaluate this using the calculator, and you get that x equals 2.97. Hence, my point is 2.97, 0. So, what is rather not difficult but slightly not nice about this question is that there is a lot of algebra involved, but otherwise the concept is pretty redundant. Anyway, pause the video to copy this down if you will, and I shall begin question 3 shortly. So question 3 came in paper 2, May 99, question 5 III. Kindly take a minute and attempt to solve this question. Pause the video and the answer shall follow through shortly. So I am given the equation of the parabola y squared equals 9x, and I need to verify that the point 4, 6 lies on the parabola to solve question A. So I shall simply substitute 4 into the x and 6 into the y to check whether they satisfy the equation or not. So this is what I did right there. Y squared equals 9x, so 6 squared equals 9 times 4, and it is shown to me that indeed 36 equals 36, which means that this point does satisfy the equation of the parabola. So moving on to question B, we are told that the line PQ is the normal to the curve at point P, and it cuts the x-axis at Q. We want to find the equation of PQ in the form AX plus BY plus C. So we want to find the equation of the normal at P. Let's check this out. So, as usual, in order to get the equation of the line, we need a point and the slope. We are already told that the coordinates of point P are 4, 6, so we just need to find the slope. Now, in order to find the slope, I need to first rewrite this equation with y as the subject. So y squared equals 9x becomes y equals 3x to the power of half, or 3 root x. And in order to find the slope at point P, I shall simply use the calculator to do so. So I've written down my equation onto the calculator, 3x to the power of half, right there. And next I shall click on trace. And there is the graph of my equation. I want to find the slope at the point where x equals 4. So I shall press on second, trace, find dy by dx. And I want this when x equals 4, so I shall just click on 4 right there, then click on enter, and the calculator tells me that the slope is 0.75 or 3/4. So of course this is the slope of the tangent or the slope of the curve. If I want the slope of the normal, I need to flip and switch. So since the slope of the tangent is positive, the slope of the normal shall be negative, and the 3 and the 4 are inverted to give me 4/3, or rather negative 4/3. Now that I have the slope and a point right there and right there, I can use the point slope formula, as you can see right there, do some simplification and expansion and so on, and you need to write the equation in the final form that they requested in the question, which was ax plus by plus d equals 0, and you need to make sure that the format is similar to that. So let's check the requirement of BII. So we have completed BI and we have found the equation of PQ. Next we need to find the coordinates of Q. And this is similar to the previous question, where we were told that Q is the point where the normal cuts the x-axis. So we have the equation of this normal line right there, and we want the coordinates of this point, and we should know that the y value at Q is 0 because it lies on the x-axis. So since the y value is 0, I can just plug 0 instead of y into this equation. Of course, the equation that I got, the one that has numbers, not a and b and c. So if I plug 0 instead of y in this equation, I can find the value of x accordingly. So let's check out how to do that. So as we've mentioned, since Q belongs to the x-axis, then the y coordinate is 0. So I shall plug 0 into this y right there and use that to find the x, some simple algebra, and I have found the x to be 8.5. Hence the coordinates of Q are 8.5 and 0. So take a minute to copy this down if you will. This concludes our video. I hope you have found it beneficial.